The continuation of topic work, energy, and power assignment. In this question, you can also use the chat to answer a question. Two students, P and Q, of equal mass climb to the top of the mountain. They both start their climb from a same vertical height. The student P takes 2 hours to climb a short, steeper route, where student Q took 3 hours to climb a longer, less steeper route. Which row of the table correctly describe the gain in the gravitational potential energy and the power developed by student P compared to student Q? So what could be the right answer for this? The gain in the gravitational potential and the power. You can use the chat to answer. Don't bother about answer being wrong, as this is just a practice. What could be the right answer for this? They both reach the same level. Different routes, but they reach the same level. So if they reach the same level, when we compare the gravitational potential and they have the same masses, so when we compare the gravitational potential energy, it will be mgh, and here also it will be mgh. So they both have the same mass, they have the gravity same, and they reach the same level. So the same gravitational potential energy for P and Q. So either C can be an answer or D can be an answer. And then when we can calculate the power is work divided by time. So they have the same gravitational potential energy, but the time interval is different. P takes 2 hours to climb, where Q took 3 hours to move. So because the P took shorter time, so means P generate more power than Q. That's why C should be the right answer. Is it clear, this one? This is work done by the spring, because that's our next topic. In question 9, work, energy, and power. A jet ski is a jet-propelled vehicle that moves across the surface of the water. To propel the jet ski forward, the water is drawn through an intake and then it is ejected through a water outlet at a high speed. Explain why the cross-sectional area of a water outlet is smaller than the cross-sectional area of an intake. So why there is a difference in the cross-sectional area for intake and out? So yeah, you can relate with the pressure or you can also relate with the force. Because the idea is that, yeah, you can relate, you can mention the term pressure or you can also refer the term force as well. Look, the intake area is greater, but outlet area is smaller. And the amount of the water which enter every second, the water intake and the water which is going out should be same, because the total volume is constant. So it cannot take more water and give out less water. So as a result, what will happen? The water which is going in and the water which is coming out should be same. So as a result, what will happen? The flow rate must be constant because the volume is constant. That the propellant volume is constant. So if 2 meter cube of a volume enters in, 2 meters should leave. So as a result, we have the formula that volume is area multiplied by length. So, or you can also take the volume is area multiplied by length. So, because the outlet is having a smaller area, so the distance moved by the water, the horizontal distance moved by the water should be greater, or the water will come out at a higher speed. And when the water will come out at a higher speed, it means there will be more force. There will be more force on the water. As a result, the water will apply equal and opposite force. So as a result, it will propel, because what will happen, like it take in water and gives out water. When the water is coming at a high, because the area is narrow, so volume is area multiplied by length. Area is less, volume is constant, so the length should be greater. Like water should go a greater length, or in a short time, it should move faster. So the force on the water should be greater. When there is a greater force on the water, as a result, there will be greater force. The water will exert an equal but opposite force on the jet ski. So it will have a greater acceleration, or it will accelerate the jet ski. Is it clear, this explanation? Anyone having a doubt or a question in this? So water which is coming out through a small area, so it should move faster. If it has to move faster, so there must be a greater force on the water. If there's a greater force on the water will apply equal opposite force, which cause an acceleration to the jet ski. Using Newton law of motion, how ejection of a water at high speed result in a forward propulsion of a jet ski. So this is the same thing. Just now I explained the idea that what will happen according to Newton pair force, when the water is pushed out, the water will apply equal but opposite force. As a result, there will be a resultant force on the jet ski, and that resultant force will cause an acceleration. So according to Newton's second law, there is a resultant force on the jet ski, and that resultant force causes an acceleration to this jet ski. A man on jet skis heading away from the coast at a speed of 19 meters per second, and a 30 degrees to the east, or as shown, there is a current of a water which is 6 meter per second due north. Velocity of a jet ski has been drawn to scale on a vector diagram, as you can see. Like this length is representing 1 meters per second. Complete the vector diagram to determine the resultant velocity. So this is a position in which a jet ski is moving, but there is a current of a water due north, 6 meter per second. So how to draw 6 meter per second? We have to draw like 6 meter per second means, because 0.5 centimeter is 1. So 6 meter per second will be 3. So I will draw a line of length 3 centimeter, which is representing 6 meters per second. And how to work out the resultant? From tail of the first, when I join the tail of the first to the head of the last, I will get the resultant. And how to know the magnitude of the resultant? I will measure the length by using a ruler. I'll measure the length and I'll get the magnitude of this resultant. And to know the direction, if they ask to work out the direction, I can use a protractor, resultant velocity, and the direction of a jet ski. So direction of a jet ski, I can measure this. I can measure the angle from the original, or I can also measure the angle from the north. Or I can also draw a compass here. I will have north, south, east, west, and I can measure this angle, or I can also measure this angle. I can mention south of east of south, or this one it will be south of east. The next question, a box of mass 5 kilogram is moved from a ground to a shelf at a height 1.5 meters. A student is asked to calculate the energy transfer as the height is increased. The student could use either of the following formula. Explain how two formulas are equivalent, like how these two formulas are same. So we have to just show that how these two formulas are same. Work done is force into displacement and gravitational potential energy is mgh. So usually whenever there's a work done to lift an object, the work done, the change in work done is equals to change in gravitational potential energy. Work done is force into distance. Whenever you are lifting an object, the force is equals to weight and the distance moved is equals to height. And in that case, it will weight is mass into gravity, so it will be equals to mgh. So we'll just say work done is force into distance and work done when move the object vertically is gravitational potential energy. And force is a weight and the distance moved with the height, so it will be mgh or the change in the height. So mg delta h or h you can also say because the starting height is 0. Calculate the increase in gravitational potential energy. So we'll just use mgh and we'll get the increase in gravitational potential energy. These are some questions. More we'll do next session.